All right, the next way that we can measure location is doing something called finding a z-score. And a z-score is measuring the exact standard deviations an observation is above the mean or below the mean. It is a way to measure how unusual something is. The higher the z-score, the more unusual the observation is. In a normal distribution, and we'll talk about that later, but in a normal distribution, a z-score that is greater than 2 or negative 2 is considered unusual. Let's look at this example here. Jack throws a football 50 yards. The distribution of football throws is roughly symmetric with a mean of 35 and a standard deviation of 10. Now notice it says calculate the standard score. That is the same as a z-score. The formula for a z-score is right here. A z-score is equal to your observation. Again, you should be writing this down. Minus your mean divided by your standard deviation. I like to use an acronym for this. Z-O-M-S to memorize a z-score formula because you're going to be using it all the time. It should be memorized even though you get open notes. You don't want to constantly be looking for this formula. We use this all the time in statistics throughout the year, okay? So Z-O-M-S, ZOMS. I'll talk about this quite a bit. A z-score is equal to the observation minus the mean divided by the standard deviation. Okay, so let's do that now for Jack. Z is equal to, observation is what is happening. Jack is throwing a ball 50 yards. Minus the mean of 35 divided by the standard deviation of 10. Now here's the catch, you guys. Type this into your calculator. Oftentimes people type it in wrong. We want to make sure we follow order of operations. So we want to do the numerator first, hit enter, and then divide by the denominator. Or we put it in parentheses if we want to do it all at once. So 50 minus 35 divided by 10, that gives us 1.5. Jack's z-score is 1.5. He is 1.5 deviations above the mean. Now, we also like to use these scores to compare things, and we'll get into that a little bit later. But right now, what I'd like to do is I would like to go do one where we have to go backwards to find their observation. So notice, okay, in this one, right, we found a z-score, okay? We found a z-score where we were given the observation, okay? We were given the mean and we were given the standard deviation and we found, okay, the z-score. Now we're going to have to go backwards. We're going to do z in reverse. You are going to be given the z-score, okay? You're going to be given the mean. You're going to be given the standard deviation and you're going to have to solve for the observation. So we're going to have to use a little bit of algebra. So let's do that now, okay? We call it finding raw scores, or we say z in reverse. Again, please do this problem with me in your notes so you have a good example of z in reverse, or in other words, called finding raw scores. Sophia's standard score for the SAT math portion of the test was 1.6. Remember, a standard score is another word for z-score. Find her raw score. That's another word for observation. If the distribution of scores for SAT math score is symmetric with a mean of 500 and a standard deviation of 100. Okay, step one, what we're going to do is we're going to write down the formula for ZOMS. We know that Z is equal to, so that's our z-score formula, our observation, OBS, minus our mean, divided by our standard deviation. Step two, we're going to plug in everything that is given, okay? So we were given our mean of 500, so we're going to plug that in right here. We were given our standard deviation of 100. We're going to plug that in right there. And we were given the standard score, or the z-score, of 1.6. So we're going to plug that in right here. So let's do that now. 1.6 is equal to, now we don't know our observation. That's an unknown, so that's going to be x minus the mean of 500 divided by a standard deviation of 100. Okay. Now we need to solve for x. The first thing we're going to do to solve for x is we need to get rid of this division of 100. So we're going to multiply the standard deviation first. That cancels, and multiply the standard deviation. 1.6 times 100, well, that's going to give us 160. So 160 equals x minus 500. And now what we're going to do is we're going to add the means. We're going to add 500 to both sides. So we get x is equal to 660. And that's the score Sophia got on her SAT math portion. All right, ladies and gentlemen, let's just take a look here. Let's finish up here with what we call relative scores, okay? Relative scores is what we use for comparison. So another reason we like z-scores is it helps us compare things that are in like two different units or two different population sets. It's kind of like the phrase comparing an apple to an orange, you can't do, right? It's an apple and an orange. People have used that phrase before. If you've never heard of it, don't worry. But using a z-score to compare things helps us, okay? It helps us to normalize it, I guess, okay? So we have Kevin Durant, who is 6 feet 9 inches, which is 81 total inches. And then we have Brittany Griner, who is 6 feet 8 inches, okay? Now, it looks like Kevin Durant is taller than Brittany Griner, correct? However, one is a woman and one is a man, okay? And what we can do is we can establish who is actually taller. We can compare them relative to the populations that they are in, okay? So first, we're going to assume that adult male heights are normally distributed with a mean of 70 inches and a standard deviation of 3. Assume also that adult female heights are normally distributed with a mean of 64 inches and a standard deviation of 3 inches. Who is taller relative to their peers? So anytime you see this word relative, what you want to do, step 1, is we are going to find the z-scores for each observation. We are then going to step 2, compare the z-score for each observation and answer the question. Okay, that's another reason we like z-scores, okay? So we can compare two things from different populations, male, female. Okay, so let's go ahead and let's find Kevin Durant's z-score first, because first that I read. So Kevin Durant is 81 inches. So I'm going to put Z, and I'm going to just put a K, D here so I know it's for Kevin Durant, is equal to 81 is our observation. Remember Zom's observation. Minus, now we need our mean for males, minus 70, divided by 3. Okay, so in my calculator right now, again, I'm going to type it so I don't mess up my order of operations. If I type it in all at once, I want parentheses around that. Otherwise, I'm just going to take my numerator, 81, minus 70, okay, divided by 3. And that's going to give me 3.67. I'm going to round to the nearest hundredth. Okay, so Kevin Durant is 3.67 standard deviations above the mean, okay, above the mean. Let's talk about Brittany Griner now. Brittany Griner is 80 inches. That's her observation, okay? So I'm going to say Z for Brittany Griner is 80 inches. So yes, she is shorter than Kevin Durant. But let's see how she compares to the population of other females. So we have 80 inches, and then we have the mean for females, which is 64. So minus 64 divided by the standard deviation for females, which is also 3. 80 minus 64, hit enter, divided by 3. That gives us 5.33 repeating. All right, ladies and gentlemen, now what we can do is we can compare Brittany and Kevin relative to their peers. Brittany Griner, although shorter than Kevin Durant, is taller relative to her peers, other females. Why? Because her Z-score is more extreme. Her Z-score is more extreme. Let's write that down. Brittany is taller relative to her peers because her Z-score is higher. The last thing I want to go through with you today is just how to interpret a Z-score. Okay, how to interpret a Z-score. When we interpret a Z-score, okay, we just say the Z-score is equal to blank. So we fill in the blank. This means the observation is blank standard deviations above or below the mean. Okay. So for example, with Brittany Griner, what would we do? Okay. We would say the Z-score for Brittany Griner is 5.33. This means Brittany Griner's height is 5.33 standard deviations above the mean. Okay, what did you notice here? I put it in context. So whatever that observation is, put that in context. In this case, our observation was Brittany Griner's height. Okay, Brittany Griner's height. So you notice we filled it in there, 5.33. We filled in that standard deviation again is 5.33 standard deviations. Now, why did we choose above? We chose above because our Z-score was positive. We choose below if our Z-score is negative. All right, that's it for this video. Thanks you guys so much for listening, and watch out for our next video. I will be posting it soon.